Okay, let's see the next question now. So this was the solution for question number 5. Now let's see the next question and the next task. Okay, so question number 6 is write a data step to create a new data set. New data set should have employee ID, first name, salary and bonus. Write only those bonuses which exceeded 3000. So we have to write a data step to create a new data set and write only employee ID, first name, salary and bonus, and write only those bonuses which exceeded 3000. Okay, let's see this. So in this we say if you see this question once again, new data set should have employee ID, first name, salary and bonus. Write only those bonuses which exceeded 3000. This bonus amount here, you need to assume that this bonus is calculated as 10% of the salary of employees' salary. So this completes the scenario. Write a data step to create a new data set. New data set should have employee ID, first name, salary and bonus. Bonus is calculated as 10% of employee salary, and write only those bonuses which exceeded 3000 dollar or rupees 3000, whichever currency you want to consider. So we say data, I say calc bonus. You can specify any data set name. Then I say set emart dot cells. Then I say bonus is equal to salary into 0.1. You can't write 10% because of that person sign, that number has become a non-standard number. So you'll have to write it in standard form. So the 10% you have to write it as 0.1. And then you say where, as we discussed earlier, you cannot write something like this where bonus is greater than 3000, because the moment you write this, SAS will start searching this variable bonus in your input dataset cells which is not present there, and this will give you an error saying that bonus not found. So you have to find out some option which does late subsetting. Where does early subsetting? So we have an option called as if, which is a PDV level option, which will be fired on your PDV data. And in PDV everything is available. The variables which are coming from your input data set, the variables which are coming from raw file, the variables which are computed, all your variables including automatic variables are available in PDV. So you have to apply an option that works on PDV level. So you have to say if bonus greater than 3000, and then we say run. We need to ensure that only some 4 variables are written to the output dataset. So we'll say keep employee ID, keep employee ID, first name, salary and bonus. Now if I write proc print, I say proc print data is equal to emart dot calc bonus. Sorry, emart is not needed because my new dataset is written to work, so only calc bonus is enough, and then I say run. So as you see, these are the 31 observations which are written to my output dataset. So this is my employee ID, this is employee name, first name, these are the salary values, and these are the bonuses. And if you see, all these bonus amounts which are written now greater than 3000. So none of the bonus amounts are less than 3000. So this is the solution for the sixth question or sixth assignment. Let's see the next task, question number 7. So question number 7 says, write a data step to create a new variable bonus, conditionally assign a bonus of 500 if the country is US, else 300 for US. Frequency of bonus is once a year, and for Australia or AU it is twice a year. So this is what we need to write. Create a new data set. In that new data set, you introduce a variable bonus, create bonus conditionally based on the country of the employee. If the country is United States, bonus is 500. If it is Australia, bonus is 300. And we need to also print the frequency of bonus, which is once a year for Australia and twice a year for US. So frequency of bonus is once a year for US. So if you see, this is for US, frequency of bonus is once a year, and for AU it is twice a year. So let's do this. This won't require much time. So I say data, and then I say calc bonus, and then I say set emart dot cells, and then I say if. So in this case I'll have to use the decision construct if then else. So I say if country is equal to US, then bonus is 500. I need not check the second condition because I have only two countries in my dataset, US and Australia. So I checked for US. If it is not for US, the only possibility is that the observation is of Australia. So I say else bonus is equal to 300. And then now I can say run. Let's first test with this criteria, and then after this we'll add the frequency of bonus. So when I execute this, proc print this, proc print data is equal to calc bonus and say run. So for US, bonus is coming as 500 and for Australia it is coming as 300 as you see. Now let me add the frequency of bonus. So after bonus I say frequency. This is not a keyword, it's just a variable to which I want to assign some hard-coded constant, so once a year or twice a year. So if the person is from US, bonus is once a year. If the person is from US, bonus is once a year, else it is twice a year. So I say freq is equal to twice a year. Now if I execute my code in this form, it will not work because it seems when we implement decision making if condition, you can execute only one statement when the condition is true or false with this form of this decision construct if then else. So if you try to execute multiple tasks or if you have multiple executable statements in your if then else, this is going to give you an error. So it's saying there is no matching if then clause. So what you need to do in this particular case, when you have more than one executable statement, you need to ensure that those executable statements are specified within do end block. So this is my do block, and once you are done with all your executable statements, you'll have to say end. So you have to ensure that all your statements are embedded within do end. Similarly here after else you need to say do, and once you are done with all your tasks you need to say end. So this do end is mandatory to have in case if you have more than one executable statement. Now if I execute this, I'm sure this is going to compile successfully and show me my desired output. See, I'm not getting an error now, and if I highlight this and execute, this is how I'm getting my data. So I'm getting once a year, and for Australia it must be twice a year. If you see this twice a year values which are printed, it is not coming completely as twice a year. Rather, it is coming just twice a and then YEA. The last character of year is missing because when you create a variable conditionally, the length assigned to that variable is the length of the first value. So if you count the length of this frequency, this is 1, 2, 3, 4, 5, 6, 7. You need to count spaces also. 8, 9, 10 and 11. So when frequency is created, first time it is assigned a length of 11 bytes, and once in SAS a variable's length, type and name is fixed or assigned, it cannot be changed. That's the reason why when you assign twice a year, it tried adjusting this twice a year in that particular length of 11 bytes and it failed to do so. So it has trimmed this last character R and it has accommodated this 11 characters in that particular length. So in this case, you need to ensure that either you check this condition first, so that twice a year is responsible for fixing the length of frequency, or you pad some extra spaces when you are printing this message once a year so that more length is assigned to this variable frequency, and this twice a year will easily fit into that particular length. Or you can avoid all this and ensure that the length of frequency is not controlled conditionally like this, but it is a standard length that you have given, that you can do by specifying a length statement here. So you can say length, frequency, and then you assign whatever length you want. You can say $15 or 20 or whatever length you want to assign it to it. So now if I execute this once again, so it has created my output dataset with 165 observations and 11 variables. Now if you see, this was coming correctly earlier also. We need to check that twice a year whether now we are getting that R thing in twice a year or not. Okay, so as you see, in all twice a year values, now we are seeing R also appearing. So it's displayed properly as twice a year. Okay, so our next question is, we have to perform a concatenation operation. So the question is asking to concatenate two datasets, Denmark and France, having similar structure. So we have two datasets having exactly same structure that we are asked to concatenate. And then we have to concatenate two datasets, Denmark and Canada, having non-similar structure, and ensure that similar values are written under single column. So we need to first create these data sets and then start our concatenation operation. So we are going to demonstrate two things in this concatenation process: how to concatenate similar data sets, meaning data sets which have similar structure, and data sets which have non-similar structure. So we need to create those data sets quickly. So let's create this dummy data sets for this demo. So we'll create three data sets: Denmark, France and Canada. So I say, so we'll use data lines to create this data set. I say data EMPS DK, say this is representing Denmark data. I say data lines. Now before this, let me specify the structure for this data set. I say input EMPID, FName and country. FName is character, country is character. Then I say data lines. I say employee ID 101, first name is say John, and country is Denmark. This is 102, name is Mike, country is Denmark. Let's say these are the only two observations that we want in this data set. Now I say run. I highlight this and execute this data step, which has created this data set Denmark EMPSDK with two observations and three variables. Now let me create a similar data set to represent the employees of France. So I say data EMPS FR. EMPS FR, Then I say input. We'll keep the structure of this data set similar to that of Denmark. So I say input EMPID, fname, dollar, and country, dollar. Then I say data lines, I specify the employee ID as say 111, and then we say first name and country. Then we say 112, that's all. We'll write only two observations in each of the data sets. Now I create the third data set. I say data EMPS Canada, data lines, data EMPS CA, data lines, and then I say before this input, and I say EMPID. So in this data set I want EMPID, fname, and reason. So if you see, I have changed the third variable in this data set. In my previous data sets, the third variable was country, but I have kept the variable name as reason for this data set. So I say data lines, say 1 to 1, let's specify the first name, and the reason. So we say reason is Canada. Canada. Take it in next line. Insert. We'll clear the log. So now we have three data sets. Let me proc print them quickly and cross check. So I say proc print data is equal to EMPS DK. Then I have, let me write all three proc prints. We cannot print all three data sets together. I say proc print data is equal to EMPS FR. Then I say proc print data is equal to EMPS CA. So this is what we have in our first data set. This is what we have in our second data set. The structure went wrong for the third data set. We just missed this dollar sign. So they were written as numeric, and when we supplied character values, there was a mismatch. So just say fname dollar and reason dollar. And now if you execute the third proc print, which was earlier showing fname and reason missing, now it will have proper values written. Now Let's perform the concatenation task where we'll try concatenating first the first two data sets and then we'll try concatenating it with third one. So there is no issue concatenating your data sets as long as you have matching structure or similar structure. You just need to write a simple code where you just say data. Suppose I say EMPS all, where I want to combine Denmark and France employees data. So I just say data EMPS all and then set followed by the names of those data sets. So I say set EMPS DK and then EMPS FR. Then I say run. Clear this output window, clear the log. Now we write a proc print. So proc print data is equal to EMPS all and run. So if you see here, I combine data from both those countries, Denmark and France. So if you see, the first two observations are coming from the first data set and the last two observations are coming from the second data set. So John and Mike are from Denmark and Harry and Peter are from France. Now let me combine this EMPS all with the third data set. So we say data EMPS all in one, and I say set EMPS all, where we have employees from Denmark and France. This we want to concatenate with EMPS Canada. But it seems in EMPS Canada we have a variable that does not match with my previous two datasets third variable, that is country. But the kind of values that it contains is same. So in country also I had the country name, and in region also I have the country name. But because the variable names do not match, the output dataset will have two different variables, country and region, which will contain similar values. So if I say run, and execute this, I say proc print data is equal to EMPS all in one, then I say run. So if you see this, I'm getting the first four country values coming under country variable, but the last two country values coming under region, because in our third data set, that is EMPS Canada, instead of country we had the variable region. But since we know that both these variables are containing similar values, having them in two different variables is not will not look good. So we need to ensure that all these country values are written under one variable, that is country. So you need to ask your business users exactly what they want to see in the output data set, whether they want country or region, and then accordingly you can rename one of these variables. Let's say people have agreed to have country in the output data set, so we have to rename this variable region to country so that this values these two country values are written under country variable. Currently they are part of, they are appearing under reason because currently these two variable names are different. But once we rename one of these variables and make it equal, these values will come under country variable. So during the concatenation process, you can use this option as we discussed earlier also. So first of all, identify the data set that contains the variable that you want to rename. So let's say it's the second data set, that is EMPSCA, which had reason. So I say set EMPS all, EMPSCA, and then I say rename is equal to reason is equal to country. Rename is equal to reason is equal to country. Execute this once again and proc print it. Now if you see, I'm getting my values correctly. So I'm getting all my employee IDs under employee ID variable, FName under FName variable, and all country values under country variable. Okay, so now there is no reason variable written. Now here in this case you have renamed reason temporarily in this particular data step. So reason is renamed as country only in PDV when it was about to get written to the output data set. You are not renaming the original variable reason which was part of your EMPSCA to country. If you proc print EMPSCA, you still have reason as reason only. So reason is not renamed as country. This renaming is going to affect only the output data set and not the input data set. So if I write a proc print for EMPSCA, you will still see the last variable as reason. So remember one thing, when you write rename is equal to option, that affects only the output data set and no way you can affect the input data set. So this was the solution for our question number 9 of this assignment. Now let's see the last question, which is write a code to create a PDF file of the output generated and store it on your disk. We can capture the same output, or maybe we can issue a proc print and generate some output and try capturing that output and storing it in a data set. So let's write a proc print. I say proc print, or we already have one, this proc print, this output that I have generated, I want to capture and store it in a PDF file. So this is what I need to say, ODS PDF file is equal to, and then you need to specify the name of the file. I say cells.pdf, and then at the end of it you need to say ODS PDF close to close this destination. Now if you execute this, SAS is going to generate a PDF file at your current location. If you want, you can change that location and say I'm saving it in at my desktop. I say save. It is trying to show me a preview, but since we do not have Acrobat Reader in this environment, virtual machine environment, it is unable to display that. But it has created that PDF file. So if I just go to my desktop, this is the file. I can take this file from here paste it to my client desktop and try opening here if you see PDF installed. So this is the file. Even the client machine does not have PDF, but this is the PDF which is generated, where the output of that proc print was captured and stored. So please remember, this is how we discussed during our regular session also, when we were covering this particular topic, how to generate different types of files like PDF and HTML and RTF, etc. So to generate an HTML file, you just need to say ODS HTML, and here while closing you say ODS HTML close. To generate an RTF, you need to say ODS RTF file is equal to file name, and here you say ODS RTF close. So this is how you can capture your results and store it in a persistent file, and you can share this file with the audience or people or users who do not have SAS configured on their machine. Still you want to share your output with them. So with this we completed all the questions of our second assignment. We have one more assignment, and that completes most of the topics of this base SAS discussion. So we'll see a few more questions. Okay. So we have few more questions. Let's attempt questions from this also. So in my next assignment, the first question is write a SAS program to create two new data sets, US female and AU female, and then read cells dataset to create these new data sets and ensure that only female data is written to these new data sets. Let's see the solution for this task. So we'll create a new data set where we'll ensure that the data is segregated, that is Australia data is written to Australia data set and US data is written to US data set, and then we'll write a criteria to subset our data based on gender. So I say data US female and then AU female, and then I say set emart dot cells. I say if country is equal to AU or say US, then output. So if country is equal to US, then output. There is one more criteria. I say if country is US and gender is equal to F, then output US. else if country is equal to AU else if country is equal to AU, and or I can instead of specifying these two conditions in this decision construct, I can also write a where statement to subset my observations, and that way it will look simpler than this. So I just say if country is US, then output US, I mean US female, else output AU female, and then we say where gender is equal to F, and say run. We create this. So my first data set has 41 observations and 9 variables, and second data set has 27 observations and 9 variables. So this 41 and 27 are representing the number of females in US and Australia. So if I proc print and say proc print data is equal to EU female and run, just to verify my results, so if you see, all these 27 observations are from Australia and all these genders are F. Similarly, if I say proc print data is equal to US female and run, so if you see, all these 41 observations are from US and all these genders are female. So this is how I'm writing my data to this appropriate data sets. Okay, the next task is write a SAS program to create two new data sets named US customer and AU customer, and then ensure that only 4 variables are written in US customer and 5 are written to AU customer. Variables in US customer are first name, last name, gender, country, and in AU customer first name, last name, gender, country, and salary. Okay, let's see the solution for this task. So we say data separate DS. So we see data separate DS, set imart dot cells, I say if in our question they have given the names of two data sets, that is US customer and AU customer. So let's, instead of writing this name, let's follow the naming convention which is given in the question. So I say data US customer and AU customer. Data US customer and AU customer. I say set I emart.cells, and then I say if country is equal to US, then output US customer, else output AU customer. And then I say run. In my previous code as well as this code, if you see, I have in my data step I have specified multiple dataset names. So as you know, we can create as many datasets as you want in a data step, in a single data step. These two names are representing my output dataset names. This is my input dataset, this is my decision construct where I'm checking if country is US. Then I'm doing an explicit output where I'm instructing SAS that if the current observation in PDB is of US, meaning if the country value is US, output this observation immediately to US female, else output it to AU female. So based on country, it is going to redirect the data to either US female or AU female. And then we have put a criteria. So before the data gets written, so first of all it is segregated based on country, and then it is segregated based on gender. We are saying where gender is equal to F to ensure that only female data goes to our output data sets. We are using that explicit output in our current demonstration also, where again we are checking the country, and based on that we are redirecting our observation to either US customer or AU customer. Now we have been asked to write different number of variables in each of these data sets. In this form, if you execute the code, it is going to write 9 variables in both the data sets. But it seems we want 4 variables for the first data set and 5 variables for the second data set. So we cannot write a normal drop or keep statement here, because if you write a normal drop or keep statement, it is applied to both the data sets. And if you write multiple drop or keep, your latest drop or keep will override the previous one. So the latter overrides the prior occurrence of drop or keep. So ensure that you have written this drop is equal to or keep is equal to options instead of using normal drop keep. So you can use these options, drop is equal to or keep is equal to, along with your dataset name. So just say keep is equal to employee ID, first name, gender and country. In my second data set, I say keep is equal to employee ID, first name, gender, country and salary. This is what you need to write. Instead of writing normal drop or keep, which is going to affect all the data sets equally, you write this drop is equal to or keep is equal to options at data set level, so that only these variables are written to your output data set. So now if I execute my code, and say proc print data is equal to US customer, run, and I say proc print data is equal to AU customer, and run. This is what we have written in our Australia dataset. So Australia dataset has 63 observations and 5 variables, and United States dataset, US customer dataset has 102 observations and 4 variables. So this is how we have written different variables, different number of variables to each of the datasets that we are creating in our data step. So this was the solution for the second question. Now the next question is, write a SAS program to calculate accumulating total sales till 15th April and use APR sales dataset for this particular task. So again, if you try to recall the accumulating total concept that we discussed once before, this is how its form was. So say data accumulating total APR, then you say set APR cells. This APR cells dataset is in PRG2 folder. If you see our current path, that's pointing to PRG1 folder, meaning the library reference that we have is containing datasets which are populated from PRG1 folder, and you will not find, okay, I can see APR cells here also. So we can use this dataset. So I say data accumulating total ACC total APR, set APR cells, and then I say month to DTE, assume that this is my accumulating total variable, plus cell amount. If you remember the structure of this data set, let me write quickly a proc print. So I say proc print data is equal to accumulating total, we say mart dot say APR cells APR cells, and then say run. So if you see data of this data set, this has two major variables, cell date and cell amount. So this is the code that I have written to compute accumulating total data ACC total APR, that's my output data set name. Then I'm saying set APR cells, this is my input data set. Then I'm saying month to date plus cell amount. So this is a sum statement which is going to create the variable on left hand side of the plus operator. It will initialize the variable with 0. It will sum the cell amount value to this initial value 0, and when it is adding the next cell amount, it will retain the previous month to date value. So this is going to give me the retain feature. In case if one of the cell amount values is found to be missing, it's simply ignored. So these are the good features that I have when I use the sum statement. Since we have been asked to restrict this result till 15th April, we just need to write a criteria. If cell date is less than or equal to, you need to specify 15th April in this particular format. You need to say if cell date is less than equal to 15 APR 2007. These dates are some dates of year 2007. So in this proc print, you can format and cross check that. I can say format cell date, format cell date, date 9 dot, just to cross check in which format I have the date values in my data set. So if you see, all these dates are April dates, we have been asked to restrict this accumulating total and calculate only till 15th April. So this is how you need to specify the criteria to restrict it to 15th April. You need to say if sell date is less than equal to 15th April 2007 D. If you remember this, we discussed earlier also, when you are writing a criteria on date values, it seems only this date format is allowed in SAS expressions. This date 9 format or date 7 format, you can write 2007 or 07. So only if your date is in DD, MMM, YY or YY format in inverted quotes followed by this constant D, you can write a criteria on date. You cannot use any other date format like your DD, MMYY or MMDDYY or week date, word date format. It's only the date 9 format or date 7 format which is supported in date criteria. So I clear this output window, this log window, execute this code. So file work.apr cells data does not exist. This APR cells that we are accessing is part of our library reference. So we have to say mart.apr cells. Earlier expression was as if we are accessing it from our work library. This is not only the output datasets we are writing in work. All input datasets we are accessing from that particular path which has been referred by this library reference in mart. So when you get such error messages in SAS, they are very self-explanatory. So you can easily diagnose the error and rectify it. So now if you see, there are 30 observations there are 30 observations in my input data set for 30 days of April. But since I have restricted my result set to till 15th April, it is writing only 15 observations and 3 variables to my output data set. So if I proc print data is equal to, I specify the name of the output data set which is ACC total APR, and then I say run. So if you see, this is restricted till 15th April. You can format the date value and see. So I say format cell date 9 dot. Format cell date 9 dot. So if you see, the last date which is printed is 15th April. So this is the solution for question number 3. Question number 4 is write a SAS program to create discount dataset using offers.dat file. Ensure that only those order dates are written to the new dataset where discount is more than 15%. So we have to use a raw file in this case, which is offers.dat. So we go to this path C drive, SAS Foundation, PRG2, and we have this offers.dat file. This is the file. So we have to create a data set based on this data and ensure that only those discount values are written where it is more than 15%. If you see the position of these data values, let's say some business users have suggested that you treat the first 4 values as customer type, second as offer date, third as item group, and fourth as discount percentage. If you see the position of customer type, it is 1 to 4. Offer date is 5 to 12. This is 5, 6, 7, 8, 9, 10, 11, 12. 13 is a space, and 14 to 21. 14, 15, 16, 17, 18, 19, 20, 21. 14 to 21 is item group, and 22 onwards, 3 digits are discount percentage. So please keep these positions in mind, and you can go back to your code editor and write a code to handle that file. If you compare this raw file with the previous one that we handled, sales.csv, that was a list raw file, and this is a formatted raw file. And I hope you remember the technique to handle the formatted raw file. Formatted raw files are handled based on their positions. So I say data, discount, then I say in file, let me specify. Since my file is in prg2 folder and currently this is pointing to prg1, let me specify the complete path for my file, where I say C:, SAS Foundation, prg2, and the name of the file is offers.dat. Then we say input, specify the position of the first variable value, which is 1. So I say input @1, read the value which is starting at position 1 as customer ID, say, and assign a length of 4 numbers. So I say @1 cust ID 4 dot. Then I say @5, call the next value as offer date. This is 5th to 12, that is 8 characters. So I say $8 dot. Then my next value is 13 is a space, and 14 is the next value beginning. So I say @14 item category this is 14 to 21, that is 8 characters again. So I say $8 dot. This offer date you cannot write $8 dot because SAS stores dates in numeric format, and the date which was given in the raw file was a non-standard numeric format. So you have to specify an in format to handle this date, and this was mmddyy8 dot. So it was US based data and the length was 8. So it was mmddyy8 dot. If you see the data again, this is how I had my data. This is representing month, this is representing date, and this is representing year, and the entire length of this is 8 bytes. So you need to say mmddyy8 dot. Then item category is starting from 14th position, it is 8 characters, and discount is starting at 22nd position. So I say @22 discount, and specify the length for discount as %3 dot. This is the in format that you need to specify for discount, which has a % sign. And you have to specify a subsetting criteria and ensure that only those discount values are written which are more than 15%. So I say if discount greater than, I cannot write 15% because SAS will consider that as non-standard value. I need to say 0.15, and then I say run. So hope this program is clear. We are accessing data based on their positions. These are the positions of my data. And I'm handling the two non-standard values of my data. One is the offer date and the second one is the discount value. Offer date and the discount value. Now if I execute this code, and proc print this. Proc print data is equal to discount and say run. See, these are the discount values. So it seems only 8 observations are written, and if you see all these discount values, they are more than 15%. You can format the discount while printing just by saying format discount percent dot. No need to specify the width while applying that format. SAS will automatically calculate the width of the number. So just see all these percentage values are greater than 15%, 25, 25, 20, 20 and so on. You'll have to write the subsetting if condition here because this discount variable is created by handling that raw file. It is not a part of some input data set. So you cannot write where because it seems where works only for input data set variables. So you have to say if and then discount and then whatever criteria you want to apply or specify on discount. So hope this demonstration is clear to you. Important thing of this demonstration was this: how to write the subsetting criteria on this discount variable. And even in previous demonstration, how to write a subsetting criteria on this particular date. So that was the interesting fact of this question or task. Now our next task is create a new data set. Write a SAS code to create a new data set and compute sum of all quarters from employee underscore donations and write it to a new data set named contribution. So let's see this. So I say data total contribution. That's the name of our new data set. Let's keep it short. Let's say total contrib, and then we say set imart dot employee underscore contributions. Set imart dot employee underscore contributions. Sorry, it is employee underscore donations. Before we complete processing of this task, let's see what kind of data we have in employee underscore donation. So I say proc print data is equal to imart dot employee underscore donations. And then we say var employee ID and then quarter 1 to quarter 4 and say run. So as you see in this data set, we have different variables, but then these are the variables that we need for our task. So we have employee IDs and there are 4 quarterly donations given by these employees, donated by these employees. So I have quarter 1, quarter 2, quarter 3 and quarter 4. We have been asked to compute total of all these quarters and write it to a total variable. That's our task. So we have to compute a new variable, say total, which is sum of all these quarters. So you just need to say sum of quarter 1 hyphen quarter 4. That's all. And we say keep employee ID quarter 1 to quarter 4 and total to a new data set. Now if you proc print and say proc print data is equal to total contrib, so it seems there are some 124 observations written to total contrib, as you see this log when I executed my data step. So proc print data is equal to total contrib, and then I say run so as you see now, this is how my output is written. So if you see for the first employee, total is 25. For second employee, it is 15 plus 15 plus 15 plus 15, that is 60. For third employee, it is 20 plus 20 plus 20, 80. For fourth employee, this is the total. For fifth employee, this is the total, and so on. So this is how we computed total of all quarterly donations given by these employees. So this is the solution for our task where we were asked to compute the total of all these quarterly contributions. So with this we completed the solution for that particular question. In our next session, we'll see some more assignments and the remaining assignments of this particular set. So we'll come with some new interesting demonstrations and examples in our next discussion. Thank you very much.